This is Ben McGahee with Yamie Chess. I'm going to be your math teacher today. Yamie Chess is a math learning aid based on classic chess that helps students in math and science education for school. In this lesson, we will learn about times tables, or multiplication tables, numbers 1 through 12. And so we have the row of numbers 1 through 12 and the columns 1 through 12, and we're going to multiply each of the numbers together to get the numbers for our table. So let's start with the ones tables. So we're going to do 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. So the rule here for the ones is that any number times 1 is itself. 1 times 4 is 4. 1 times 5 is 5. 1 times 6 is 6. 1 times 7 is 7. 1 times 8 is 8. 1 times 9 is 9. 1 times 10 is 10. 1 times 11 is 11. And 1 times 12 is 12. So those are our ones tables. So any number times 1 is itself. Okay. So let's move on to the twos tables. So we're going to start with 2 times 1. That's 2. 2 times 2, we just add 2 more to 2, we get 4. 2 times 3, that's like 3 2s. 2 plus 2 plus 2. So 2 plus 2, 4. 4 plus 2 is 6. So we're just adding 2 each time. So 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16. 2 times 9 is 18. 2 times 10 is 20. 2 times 11, 22. And 2 times 12 is 24. Okay. So notice here that with the twos tables, you're just counting by twos every time. So all the numbers are 2 greater than the one before. Okay, so let's move on to the threes times tables. So we have 3 times 1 is 3. And then 3 times 2, that's like 3 plus 3 is 6. 3 times 3, that's another 3 added to 6, it gives us 9. 3 times 4, another 3 would give us 12. And then 3 times 5, 3 more is 15. 3 times 6, that would be 18. 3 times 7, 21. 3 times 8, another 3, that's 24. 3 times 9, so we add another 3, that'd be 27. 3 times 10, that's another 3, be 30. 3 times 11, that's 33. And then 3 times 12, another 3 is 36. So those are our threes times tables. It's just like counting by threes. Okay, let's move on to the fours times tables. So we have start with 4 times 1 is 4. 4 times 2 is 4 more, it's 8. 4 times, what's that, 3? And gives us 4 more is 12. 4 times 4, or 4 is 16. 4 times 5, so you add 4 is 16, you get 20. 4 times 6, you get 4 more is 24. 4 times 7, that would be 28. 4 times 8, 4 more is 32. 4 times 9, 4 more is 36. 4 times 10, 4 more will be 40. 4 times 11, and there's another 4 is 44. And then 4 times 12 is 48. So you're starting to see the pattern here with the multiplication or the times tables. It's like multiplication is similar to repeated addition. So if you were to take, 2 times 5, which we did earlier, that was just the same thing as 2. It's like added 5 times. So it's kind of like 2, 4, 6, 8, 10. So that's all we're doing here is just a quicker way to add things to itself repeated number of times. Okay, so let's try the 5 tables. So we have 5 times 1 is 5. 5 times 2, another 5 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. 5 times 7 is 35. 5 times 8 is 40. 5 times 9 is 45. 5 times 10 is 50. 5 times 11 is 55. 5 times 12 is 60. So we're just counting by 5s each time. And notice that the interesting thing about the 5s is that every other number either ends in 5 or every other number ends in 0. So you either have 5 and then you have the 2-digit number ends in 0. And then you have number ends in 5. Then that number ends in 0. 5, 0, etc. Okay, so let's do a 6 times table. So we have 6 times 1 is 6. 6 times 2 is another 6. That gives us 12. And then 6 times 3, what is that? That would be another 6. That's 18. And then 6 times 4, that would be 24. And then 6 times 5, that's another 6, 30. 6 times 6, it would be 36. And then 6 times 7, 42. And then 6 times 8, another 6 is 48. And then 6 times 9 is another 6, would be 54. 6 times 10 would be 60, another 6. 6 times 11, 66. And then 6 times 12, another 6 would be 72. So those are the 6s. Now let's look at the 7s. 7 tables. So we have 7 times 1 is 7. 7 times 2, another 7 is 14. 7 times 3, so another 7 is 21. 7 times 4, so another 7 is 28. 7 times 5, 35. 7 times 6, or 6, that'd be 42. 7 times 7 is 49. 7 times 8, 56. And then 7 times 9, 63. 7 times 10 will be 70. 7 times 11, 77. And 7 times 12 is 84. Those are the sevens tables. Okay, so now we're moving on up to the eights. Eights table. So we have 8 times 1 is 8. 8 times 2, 16. 8 times 3, another 8, that's 24. 8 times 4 is 32. 8 times 5 is, that's 40. 8 times 6, 48. 8 times 7, 56. 8 times 8, 64. 8 times 9, 72. 8 times 10, that's 80. 8 times 11, 88. And 8 times 12, that would be 96. So those are the eights tables. Okay, let's do the nines tables. So we have 9 times 1 is 9. 9 times 2 is 18. 9 times 3, 27. 9 times 4, 36. 9 times 5, 45. 9 times 6, 54. 9 times 7, 63. 9 times 8, 72. 9 times 9, 81. 9 times 10, it'd be 90. 9 times 11 is 99. And then 9 times 12, we can get to a 3-digit number, 108. And there's our first 3-digit number, getting into the nines. So, interesting fact with the nines tables is that when you add these digits together, the 2 or the 3 digits together, you're always going to get the number 9 or something divisible by 9. So you're going to get with 18, you get 1 plus 8 is 9. 27. 2 plus 7 is 9. 36. 3 plus 6 is 9. 45. 4 plus 5 is 9. And then 54. 5 plus 4 is 9. 63. We have 6 plus 3 is 9. So you see the pattern, right? You have 72. 7 plus 2 is 9. And then 81. 8 plus 1 is 9. 90. 9 plus 0 is 9. And then with 99, you have 9 plus 9, that's 18, which is divisible by 9. Because we have this number here. And 108, 1 plus 0 plus 8 is 9. So that's a way to keep up with your nines tables. Usually you're going to get 9 when you add the digits together. And that's a good way to check to make sure you did your times tables correctly for 9. Okay, so let's try the tens table. So we have 10 times 1 is 10. 10 times 2, another 10 is 20. 10 times 3 is 30. 10 times 4 is 40. 10 times 5 is 50. 10 times 6 is 60. 10 times 7 is 70. 10 times 8 is 80. 10 times 9 is 90. 10 times 10 is 100. 10 times 11 is 110. And 10 times 12 is 120. And so the easiest way to do these is to take the numbers at 10 and then multiply maybe 1 and then the numbers, and then you add the 0 on the end. So like with 1 and 10, you got 1 times 1 is 1, you add 0 for 10. Or if you have 10 times 3, 1 times 3 is 3, you just add 0 and in for 30. And then if you have 10 times 12, you do 12, and times 1 is 12, add a 0 on the end to get 120. And just count by tens. Okay, so we only have 2 more left to do before I give you some exercises on your own. So let's look at the 11s tables. And those are interesting. So we have 11 times 1 is 11. 11 times 2 is 22. 11 times 3 is 33. Do you see a pattern? 11 times 4, 44. So the numbers are basically the same. The 2-digit numbers are the same. So 11 times 5, 55. 11 times 6, 66. 11 times 7, 77. 11 times 8, 88. 11 times 9 is 99. And then 11 times 10, this is where the pattern shifts a little bit, and you get 110. 99 plus 11 is 110. And then you get 11 times 11, that's 121. And then 11 times 12 is 132. So when you have the 2-digit numbers from the times tables 1 to 9, your 2-digit numbers are going to be exactly the same. Same digits in the 1s and 10s places. Okay. And now time for, last but not least, the 12s tables. So let's see how the 12s tables work. So we got 12 times 1, 12. 12 times 2, 24. 12 times 3, 36. 12 times 4, 48. 12 times 5, 60. 12 times 6, 72. 12 times 7, 84. 12 times 8, 96. And 12 times 9, get a 3-digit number, that's going to be 108. 12 times 10 is 120. 12 times 11, that's 132. And then finally 12 times 12 is 144. So we complete the multiplication of times tables for numbers 1 through 12. And so an interesting thing with the 12s is that when you start with 12 times 1 is 12, you're going to get, you start with 1 for this digit, and then you see that the digits increase each time. For 12 times 2, you get the 2. 12 times 3, 3. 12 times 4, 4. And then it kind of skips a little bit, 12 times 5. But notice that these digits here is just starts with 2, and then 4, 6, 8. And then since we get to 10, that's why we skip 4 to 6, and then we add a 0, and then it starts all over again, 2, 4, 6, 8. So that way you know what the ones digits are, and that you're just going by twos each time. And then you do 0, and then this is 2, and then 4. And then the tens digits, you went 1, 2, 3, 4, and since you had to go back to 0, you got 2 more, 6, and then you go by 1, 7, and then 8, 9, then 10. And then you skip a couple because you go back to 0, 12, 13, 14. So that's kind of a nice little pattern there. It'll help you memorize the 12s digits. So what we're going to do right now is let's take a look at some times tables that you can try on your own. I have 5 multiplication problems for you to try, and feel free to pause the video or rewind the and watch me do the times tables all over again just to help you drill those. And the more you practice, the more you'll be able to memorize all these times tables. So I'll give you some time to work on this and pause the video, and we'll go over the answers. Okay, so let's go over the answers here. So the first question asks us to do 3 times 8. So if we go back to our times tables, we need 3, and then we have 8. So 3 times 8 should give us 24. And that's what we got, 24. Three times 8 is 24. So now let's look at 6 times 9. We'll go back to our times tables. And we have 6, and then we got 9. Yep. So there's 6 times 9. It's going to give us 54. And so is that should be our answer, right? 54, yep. 6 times 9 is 54. Okay, number 3, 7 times 7. 7. There's 7. 49 looks like. And that's our answer, 49. So 7 times 7, 49. Okay, 11 times 5. And then we got 5 up here. Where is it? 11 times 5. Is that it? 55, right? 55. So then we get 55. We did. Perfect. Okay, so we're going to look at our last problem, 12 times 4. And 12 and 4. There we go. 12 times 4 looks like 48. Did we get 48? Yes, we did. 12 times 4 is 48. And so those are the problems. So if you got all of those right, great job. Keep practicing your times tables 1 through 12, and you will be all set. And make sure to keep practicing until you memorize them. This is Ben McGahey, and I want to thank you for watching this lesson on times tables 1 through 12. Please stay tuned for more lessons on YamieChess.com. Have a great day.